Hello, Professor, and my dear friend. We are from section NAA, and today we are presenting a project on sentiment analysis of IMDb movie reviews. IMDb is an internet movie database, and we have 50,000 movie reviews. Group members are Shariat Shah, myself Farzan Suri, Pranav Jain, and Rishabh Sharma. The agenda is first, goal; second, data description; third, approach; fourth, project insight. In Project Insight, further subtopics are creation of dataset, assigning, training, and testing dataset, visualization of a text length, word cloud, and sentiment bar chart, pre-processing like tokenization, remove of HTML strips and noises text, remove of special characters, text stemming, and removal of stop word. Next is checking bag of words and TF-IDF model. TF-IDF stands for Term Frequency Inverse Document Frequency, applying tree model for accuracy checking. Logistic regression model, SVM, that is support vector machine model and multi-nominal naive Bayes model. Fifth, results, and sixth is conclusion. Let's move to first point, goals. The goal is to do the sentiment analysis of the IMDb movie reviews, which includes the following. Demonstration and practice of the tasks such as creating dataset from CSV file and show it. Pre-processing, which includes tokenization, lowercase the word, removal of punctuation, symbols and space, removal of the stop words, stemming, and lemmatization. Some interesting detail about the text in the dataset, and finally check accuracy of our model. As a business analyst, we can guide the manager of the organization with which we are associated about the overall sentiments of the customers, their likes and dislikes for our customer service, product quality, and pricing. In this particular instance, we can give general idea about public opinion on movie content, dialogues, direction, and other stuff related to the entertainment industry by showing positive or negative overall sentiments of our viewers. On our primary report, client can do further detailed investigation.
Thanks, Farzana. Next is data description. The data is on IMDb movie reviews received from kaggle.com, and it has 50,000 reviews in it. 25,000 are in train data and 25,000 in testing data available as train.csv and test.csv. The dataset have two variables. The first one is text, that is for the review comment text, and the second one is sentiment. This is binary, either positive or negative, based on the sentiment of the review given. Let me explain our approach towards this project. Our job is to predict from the text that whether the review is positive or negative and shall be compared with the second column of sentiments. And once we train the model with training dataset, we shall check the accuracy on testing dataset. For this procedure, our approach is very simple. First, we will convert text into the form where machine understand it. Means we will do the pre-processing work. Pre-processing work includes first one, tokenization, second is lowering the case, third one is removal of punctuation, symbols, and spaces. Fourth one is removal of other noises like web address, HTML, abbreviation, and special characters. Fifth one, stemming and lemmatization. Sixth one, removal of softwords like a, n, the, to, me, myself, etc. After pre-processing, finally, we'll run different models and then check the accuracy of those models. Here we are using three different models. First one is logistic regression model. Second one is a support vector machine model. And third one is multinomial naive Bayes model. Bored with the theories? Let's do some data visualization next. Some data visualization before the pre-processing of the corpus. This is the bar chart showing trained data character length in each review. We can see that maximum character length goes up to 6,000 in one review, and majority are in the range of 600 to 1,000. Next. This is the bar chart showing test data character length in each review. Here also we can see the same pattern that maximum character length goes up to 6,000 in one review, and majority are in the range of 600 to 1,000. Next. This is the word cloud for trained dataset. Next. And this is the word cloud for test dataset. Next. This is the bar chart showing positive and negative sentiments in trained data. Next. And this is the bar chart showing positive and negative sentiments in test data. Over to Pranav.
Sorry, Rishabh. Pranav is not accessible. Hello, Professor. I'm Shreyas. Hi, dear friends. Let me show you some highlights of the project insights. See the first and last 5 observations of the training data set by using read.csv and .head command in Python. Next. Now have a look at shape of the data set with .shape, summary of the data set with .describe, and sentiment of the data set with .value_count commands. Next. Now it's time to do the pre-processing. Here we are defining the function for tokenization and doing removal of HTML strips and noise text. Next. Removal of special characters and text stemming. Next. Now let's use the function defined earlier for tokenization and do the tokenization. After tokenization, we will remove the stopwords. Here is the list of removed stopwords. Next. Are you curious about how the text looks after preprocessing? Let's see the first review command and output of the text after preprocessing from the training data set. You might be interested to know how many words are remaining after cleaning the bag of words of our corpus. Let's have a look. It's 4,144,530 words after pre-processing. We removed more than 100,000 tokens. Next. Now let's see positive word cloud and negative word cloud. These are the codes and output of positive word cloud. Next. These are the codes and output of negative word cloud. Next. Till now, we saw data creation visualization, pre-processing, and word cloud. Now it's time for the modeling. Basically, we are going to test three algorithms as my friend Rishabh explained before. So the first one is logistic regression. Here it is visible that after training the trained data set, when we tested model on the testing data set, we got the accuracy of 68.8%. Next. But now you might have question in your mind that actually how many positive and how many negative reviews predicted correctly. So for that we created confusion matrix here. You can see that 8,965 positive reviews predicted correctly and 8,236 negative reviews predicted correctly in training dataset. More or less similar results in testing dataset. Please check TP and TN. Next. Here we created classification report in detail. You can see that overall logistic regression model accuracy is 0.69 or 69%. Now let's check SVM model. Next. When support vector machine model implemented, we found that accuracy in bag of words was 56% and in TF IDF only 50%. So it is advisable to not to consider this model as logistic regression model already gives higher accuracy. Next. Confusion matrix of SVM shows the numbers. Next. Overall accuracy of SVM model is 50%. Next. Move on to our last model, multinomial naive Bayes model. Here, when we train the model with the trained data set and tested it over test data set, we found 68.73% accuracy, which is almost same as logistic regression model. Next. Confusion matrix shows the numbers. Next. Here accuracy of the multinomial naive Bayes model is also 69%. Next. So the result is pretty clear. Support vector machine model is having very low accuracy, so we drop it and we can select any of the two, that is logistic regression model and multinomial naive Bayes model, to do the sentiment analysis. Next. Conclusion. From the above project, we can conclude the following. First, sentiment analysis is a great tool to improve the customer's satisfaction level by checking their review details and sentiments. Second, unstructured data like text, audio, video, and all in different languages can be mapped to the language which machine understands and gives desirable analysis. Here we did text sentiment analysis. Third, different models like here we used logistic regression, multinomial naive Bayes, and support vector machine model are suitable for different types of problems. We have liberty to select the suitable model after checking accuracy of different models. Fourth, pre-processing of the text is the most important task. And last but not the least, organizations can improve their top line and bottom line by doing such analysis on the data available on social media platforms related to their organization and appropriate actions. Next. Two references are as mentioned here. Thank you.